All right, so we're on to section 1.4, sets involving algebra. Now, this is not super different than what we were doing in section 1.3, but we're going to try to make this look a little bit more like a math problem, if you want to think about it that way, where we're going to introduce some unknown variable to our problem and then try to solve that variable. But these problems start the same way. So in this first example here, we have dogs at a dog show, where we have 12 dogs are black, 8 dogs have a short tail, 15 dogs have long hair, and then there's some combination of that. So we should set up our Venn diagram. So if you look through what we have in the problem, okay, we have dogs that are black. We'll put those in that circle. We have a short tail, so we'll put them over here, and we have long hair, so they can be down there. So remember, the strategy for these problems is always to start with finding what's most restrictive, or starting in the middle of your Venn diagram and work your way out. Where's the most overlap? So if we look at our statements that were given above here, well, we have one dog is black with a short tail and long hair. 3 dogs are black with short tails but do not have long hair. 2 dogs have short tails and long hair but are not black. So this one dog is what we should try to sort first. It's the most restrictive. So if we have short tails here on our right and long hair and the color black, so that one dog would go there, right? This is the first thing to sort. Okay, so now we move on to, okay, what's the next most restrictive? And we have 3 dogs are black with short tails but do not have long hair. So we know everything we need to know about those. So if they have short tails and they're black but not long hair, they would go there. Right? Okay, so do the second thing. Next we have 2 dogs have short tails and long hair and are not black. So they're giving us enough information about these dogs as well to know that, okay, short tail, long hair, and not black would go in that overlap, that intersection. So now we kind of need to know what would be in the next intersection, but that's what this problem is asking us to find. It says algebraically determine how many dogs are black with long hair but do not have short tails. So that's what we don't know. So we're going to define this as x. So x number of dogs, make that a little neater. X number of dogs are black with long hair and not short tails. So let's see now if we can fill out the other 3 subsets here with this information. So let's go back to the top. So 12 dogs are black. Well, we've already counted for 4 of these dogs, right? Already counted 4 of these. So 4. That's the black dog with short tail and long hair, and the 3 that are black with short tails but no long hair. So we are starting with 8 dogs, and we're going to subtract the ones that would go in that intersection down here. We're going to subtract our x, or our dogs that are black with long hair and no short tails. Okay, so now we'll go to 8 dogs just have a short tail. So if 8 dogs have a short tail, well, we can say we already counted already counted the ones that we've already put in that set. So there are already counted 1, 2, 3, 4, 5, 6 of them. So that means we have 8 minus 6 is 2. So we'll put that 2 there for short tail. Okay, 15 dogs have long hair. Well, we've already counted 3. And we know we have an X number of dogs that are going to have long hair and be black as well. So we'll start with 15 minus the 3 we've already counted minus the X that we don't know, which gives us 12 minus X. So I'm going to put the 12 minus X right there. And I'll put our 8 minus X for black dogs there as well. So now our Venn diagram is filled out. So how do we set up an equation? Well, let's go back. We know how many dogs there are total. 25. So we should be able to say every dog added up here in each of these subsets, all combined together should be 25. Which, if we want to write, so we're writing an equation, we'll say 25 dogs is equal to all of our black dogs. So all of our black dogs plus all of our short tail plus long hair. And of course some are counted there twice, but we only need to enter in the numbers that we've just put in the Venn diagram. So our black dogs, we have 8 minus X plus 3 plus 1 plus X. Those are everything in the black subset. So the short tail ones, okay, there are 2 that are just short tail, and there are 2 that are short tail and long hair that we haven't counted yet. And finally, the ones that are left should just be the ones 12 minus X, the long hair only dogs. And then we've everything else has been included already. Okay, and if you want, we can put these terms in brackets so you can think of it as one piece, maybe, or one number of dogs. So let's combine as much of this as we can. So we have our constants and our variables that we'll have separately. So if you add all these up, we get 28 minus X is equal to 25. So you should see that, this X and this negative X, so there's minus 2X plus 1X, positive X is minus 1X. That's where that's coming from. And then all the numbers added up are 28. And now we just need to solve for X, and we'll do so by rearranging this equation. So I'm going to bring X over to my left-hand side and bring the 25 over to the right-hand side and get X is equal to 28 minus 25, so X is equal to 3. So we have 3 dogs, are black with long hair and no short tails.